Hello everyone, and in this video I will be covering question 2 of the SACE 2012 Specialist Mathematics examination. So question 2 focuses on integral calculus, and we're going to be looking at the question and how we can solve some aspects of the question here. So first off, we're asked to use the fact that tan theta is sine theta on cos theta to show that the derivative of tan theta is sec squared theta, which is 1 on cos squared theta. So tan theta equals sine theta on cos theta, and therefore the derivative of tan theta, we use the product rule. So what we do is we differentiate the numerator. The derivative of sine theta is cos theta, and then we multiply it by the denominator. So we end up with cos theta, cos theta. Then what we do is we subtract the derivative of the denominator, so we differentiate cos theta, and obviously that's negative sine theta, and then we multiply it by numerator, so it's negative sine theta, sine theta. Then that is all divided by the square of the denominator, so in this case it's cos theta squared. Now using our trigonometric identities and the fact that we have a double negative, we know that we can rewrite cos squared theta plus sine squared theta as being equal to 1. So the entire numerator is equal to 1. This is on the Specialist Mathematics formula sheet, and it's probably one of the most common identities that you will encounter in Specialist Mathematics. The denominator remains the same at cos squared theta. So 1 on cos squared theta, as we said before, is equal to sec squared theta. So we've proven that. And we've proven that the d on d theta of tan theta is sec squared theta. So moving on to the next question, we need to find the integral of f of x dx, where f of x is sec squared x tan cubed x. So what we do is we use u substitution. Now clearly, we've just shown that if we differentiate tan theta, or tan x if you will, then we get sec squared theta. So we can see a derivative and some term in there as well. So we let u equal tan of x, and therefore du is sec squared dx, using our result from A. So therefore the integral of, and all it really is now u to the 3 du, because we've identified tan x there, we just set that equal to u, so it's u to the 3 du, is equal to 1/4 u to the 4 plus c, where c is the constant of integration. Hence, substituting u back in, we get 1/4 of tan x to the 4 plus c. Hence, we need to evaluate exactly the integral from 0 to pi and 3 of sec squared x tan cubed x dx. And this is very simple because we've actually found the integral before, so it's just a matter of evaluating the definite integral. We don't need to worry about the constant of integration because that just disappears whenever we're doing a definite integral, and so we end up with 1/4 of tan to the 4x between 0 and pi and 3. We then substitute that in to the definite integral, so we have 1/4 of tan pi and 3 to the 4, take 1/4 tan 0 to the 4, and from that we know tan 0 obviously doesn't matter, so we end up with 1/4 lots of 9, which is 9 on 4 there. Okay, so now what we need to do is we need to show that it is an odd function. In order to do this, we simply need to evaluate the f of negative x. So in order to evaluate the f of negative x, we simply need to say, well, okay, wherever there's an x in the function, and I've rewritten it out in terms of cos and tan, so we can see here that we have, cos and sine, but we have cos squared x, 1 on cos squared x for sec squared x, and sine cubed x on cos cubed x for the actual tan cubed x. And we put negative x in, and we know that the cosine is always going to be even. It's an even function, so we can rewrite those two, but sine is odd. So as a result of sine being odd, we're still going to have a negative x there, so those two are the same, but that one's not, so we're going to end up with a negative in front of our original expression, or negative f of x. So because we end up with negative sec squared x tan cubed x, the function is overall odd because we end up with the negative result. So now we need to find the value of negative pi on 3 to a f of x dx, given that 0 to a f of x dx equals 5. So what we actually know from before, sorry about that, there's a little error there, but we know that as the function is odd, which we've just proven, that the integral from 0 to pi on 3 f of x dx is equal to negative the integral of negative pi on 3 to 0 f of x dx. This is based on the fact that we actually have rotational symmetry about the origin. So hence we know that this integral here is equal to negative 9 on 4 from before. We know that outcome. So now we can say, well, the integral from pi on 3 to a f of x dx, which is what we have to find, is simply the integral of negative pi on 3 to 0 f of x dx plus the integral of 0 to a f of x dx. We know what the integral of 0 to a f of x dx is. We know what that is. So as a result, we get this integral as being 5 take 9 on 4. Thanks for watching this video. That's question 2 of the 2012 Specialist Mathematics exam. There will be more videos soon covering other questions from the exam. Let me know if you have any comments by talking in the comments section below on YouTube. Thank you very much for watching.